In this video, we're going to go over the AP Calculus AB 2018 free response question number 6. So in the first part of the question here, they give us the differential equation, they give us the slope field, and they just ask us to sketch two different solution curves. And I'm just going to sort of walk through the idea here. I'm going to do the 0, 2, which is this point here first. Just follow the lines, and it's just a nice horizontal line there that's nice and easy. And then for 1, 0, again, just follow the lines here. You're going to kind of go that way, and then over here, right here, you've got to kind of come back up. Looks like it should be roughly symmetric and then be horizontal. I'm going to go ahead and try to draw it. I have trouble with my stylus drawing nice straight lines, but we'll give it a go here. Oops, that's not what we want. Roughly that, and that, and then, oops, see how it's all squiggly on me sometimes? Sometimes it just does that, and I don't really feel like it's worth my time to try to fix it. Something roughly like that without the squiggles. Important that you draw both halves of the solution, that you don't just go to the right, but you go from the point left as well. That's often a separate point on these types of questions, on the free response questions. So there we go. There's part A. I'm going to go ahead and squeeze this down a little bit so we have a little more room to do the actual math in parts B and C. So in part B, it says, okay, use this initial condition and that given differential equation to write an equation for the line tangent to the graph at x equals 1, and then use your equation to approximate a value. So of course when we write a tangent line, we just need, we always want to think about point slope form. So for B, we already have the point. It's y minus 0 is equal to m times x minus 1. And of course you don't have to write the y minus 0, but I'm just showing for, to illustrate here that we already have a good chunk of what we need here. And it's just the m that we need, and of course the derivative gives us that. So, okay, we've got this equation, and we're going to plug in the point 1, 0 to that. So that's 1/3 times 1 times 0 minus 2 squared. Simplify all that, and I believe we're going to get 4/3, and then plug that in for your slope m. So y minus 0 is equal to 4/3 times x minus 1. Of course, again, you don't need to write the minus 0. And then that tangent line approximates f of x. Just approximates it. So f of 0.7 is approximately just plugging in 0.7 to this equation, which is then 4/3 times 0.7 minus 1. And I would just leave it like that. No need to simplify. Okay, so that's part B. Part C, it wants us to actually solve this, find the particular solution. All that means with particular solution is that when we solve, we're going to have to anti-differentiate. There's going to be a plus c, but we can't leave it as a plus c. We have to use the initial condition to find the particular solution that will go through that initial condition. Okay, so let's clear out some room here, get rid of our part B, which was approximating, and our part A, because, well, we can leave the part A. Okay, so when we actually solve a differential equation, it's super important that we remember there's only one way we know to do that, and that's to separate the variables. So when I look at my dy dx equals 1/3 x times the quantity y minus 2 squared, I'm going to take that quantity y minus 2 squared and divide it to the left, and then take the dx and multiply it to the right, so that I have everything with a y on the left, and then everything with an x on the right. So I'm going to have 1 over the quantity y minus 2 squared dy equals 1/3 x dx. And then we just anti-differentiate, integrate each of those. Antiderivative on the left-hand side, think about that as a y minus 2 to the negative second, and then you just do antiderivative power rule. Now, technically, you would need some sort of u substitution because you have not just a y to the negative second, but a y minus 2. But because the y is by itself, there's no coefficient with it or exponent on it, this minus 2 is not going to affect the integral or derivative or antiderivative, depending on which way you're going. In this case, it's an antiderivative. So we add 1 to the exponent, make it negative 1, and then divide by that. So we're just going to get negative 1 over y minus 2. And then that equals, same over here, think about this as x to the first, add 1 to the exponent, divide by that, it becomes 1/6 x squared plus c. We only need 1 plus c. If we put 1 over here on the left, an unknown constant, we would just group it over here and have 2 unknown constants added together, which, hey, an unknown constant plus an unknown constant is just an unknown constant. Some people like to solve for y at this point. I like to plug in the initial condition for x and y and solve for c first, and then get y by itself. It just seems a little cleaner to me. So if I plug in 0 for y, so this becomes negative 1 over negative 2, which is positive 1/2. And then on the right side, we're plugging in 1 for x, so this is just 1/6 plus c. And then if we subtract to the other side, we're going to get then 3/6 minus 1/6 equals c. And I'm actually going to leave that as 2/6, even though 6ths is hard for me to say. Because of what's going to happen a little later, it's going to be easier to combine because of this 6th if I leave this one in terms of 6 rather than simplifying it to 1/3. So now we take that c value and we plug it back up here, and then we solve this for y. So we have negative 1 over y minus 2 is equal to 1/6 x squared plus 2/6. And as I said, I'm going to combine this left hand or right hand side rather into one fraction. And now really I can just flip the two fractions. If you need to see how that works, I'm just going to cross multiply and then divide again. And so what I'm going to get, let me scooch this over just a little bit here if it will, or scooch it up. There we go. What I'm going to get here is 6 over x squared plus 2 is equal to y minus 2 over negative 1. I'm going to move that negative 1 over to the other side here. So I'm going to make that negative 6 over x squared plus 2. And then let's go ahead and add the 2 at the same time here equals y. And that is my equation. In terms of scoring for this one, the first step that we did, I see that that's kind of making that look ridiculous. But the first step here of separating the variables, so the y and the dy were on the left and the x and the dx was on the right. Not only is that the key to doing the problem correctly, but in terms of the way that this is scored by the College Board, that's like, it's usually half or more of the points on this question. So make sure you remember that when you're solving a differential equation, you can only solve and find a particular solution if you have only x's and dx's on one side, y's and dy's on the left. So make sure you do that first. Okay, that is number 6 from 2018.